program information in Germany so that we can talk about integration a little bit more today, since that's a focus coming up here in Maryland. Anne, do you want to kick us off then with the first couple of slides, and you just yell at me if I am not advancing in time?
Sure, that sounds great. So hi everybody, excited to talk with you today. So this is just from 2019, the State of the State reports that came out in October. And this at that point in time was their kind of coding of computer science teacher certification programs. So which ones actually were in existence. So you can see that there is a lot more certification than how many pre-service programs actually existed to prepare computer science teachers. So the one on the left are who could teach computer science or what states have certification. And then the one on the right is basically, do they have a pre-service program? So you can tell, obviously, lots of gaps here, something that we need to investigate, look at, and kind of tackle. So we can go ahead and move forward, Jen. So based on kind of an analysis of the different types of pre-service programs, we've kind of identified a couple of different buckets, I guess is the best way to say it. The first one is for generalist teachers. So those that are going to be teachers in other areas. So if they're going to be a secondary social studies teacher, what do they need to know about computer science? What are those basic kind of requirements? Many of you, I think most pre-service teacher education programs, regardless of the subject area or grade level, they typically have an EdTech course or like required to do technology. And so that's another thing that we're wondering about is, do people also require that? Do teacher education programs now, are they starting to see computer science as something that needs to be required for all teachers? Of course, I'm of the mindset that the answer is yes, but you know, you talk to different people and there's always competing interests of what actually needs to be put in there. And there's only so much time and space in the curriculum. And then, so that encompasses also generalist elementary folks as well. Then there's the more subject specific CS, those people that are specifically prepared to be able to teach computer science. And so there are two different types of programs there, which would be a standalone program. So we are preparing you to just be able to teach computer science at the elementary level or just teach computer science at the secondary level, much like you would have, I mean, I guess I could say like the standalone program, if you just had a computer science teacher, a lot of them are K through 12 at this point in time. So that would be one point here, similar to like art or music or other specials programs. Then there's the add-on or an integrated license, right? So for our elementary folks that are going to actually teach computer science, I think that's an important thing for us to look at, as well as if somebody is already going to be a math teacher or a science teacher, how do we also prepare them to be able to teach computer science, possibly in like an add-on license? Okay, we can move on. Thanks, Jen. This was also just something that we kind of looked at in terms of pathways, in terms of if we're, again, looking at, I don't know why I'm using buckets so much today, but it seems to work out kind of well. So this idea of like making sure that we're filling the buckets that our teachers need in order to be able to teach computer science. So there would be general pedagogical types of needs, CS knowledge, CS pedagogy, and then field experiences. So as you kind of look across a continuum, if we're not just looking for pre-service, but if we're looking at, you know, secondary CS teacher pathways, it could be an in-service add-on where they already have the general pedagogy and they probably already have all the experience that they need to do field experiences, but they may need more CS knowledge and CS pedagogy, which is where a lot of our professional development things come in. Again, somebody coming from a CS field would wouldn't need to have computer science knowledge. They already have that, but they would need a general pedagogy, CS pedagogy, and potentially field experiences to be in the classroom. Okay, we can move on. And so this kind of brings us to our dimensions of RCS pre-service programs that we kind of want to talk about. Again, using different ideas in terms of our grade levels, approaches, program levels. Did you want to talk about this one, Jen?
Sure. So the gentleman who presented with us was presenting about a K-9 program, so one that was for elementary and middle school teachers. That was a standalone. They did it at the undergrad, but they also had a graduate level equivalent, and it resulted in a full computer science teacher certification. I'm at the College of St. Scholastica, which is in Minnesota. We do not have any sort of certification. So the approach we've taken in our program is that, as Anne was saying earlier, we have certainly bought into the idea that all of our pre-service teachers need to know something about computer science. So all grade levels get something related to CS. And then we've also done an integrated approach instead of trying to add courses or that sort of thing. We've integrated with the subject areas that the students will be going through, and I'll talk more about that later. We have it integrated in an undergrad program. We also have a 2+2 degree completion program, and then we have a graduate licensure, like an alternative licensure pathway. And so it's integrated in all three of those different delivery mechanisms. Do you want to talk about yours, Anne?
Sure. And then I just presented two different ones here at Indiana University. So we have our K-12 CS add-on licensure, which gets full CS teacher certification. So they would have an initial licensure in one area, and then they would add on something else. So they could be elementary, they could be secondary social studies, secondary language arts, whatever that initial licensure is, and then they add on through 4 additional courses. And then I also put down here too for K-8, because in Indiana, all of our elementary teachers are required to teach computer science, and it falls under our science standards, and even our students are tested on it. So we try and prepare them through our one EdTech course.
So in terms of the College of St. Scholastica, like I said, our goal is for all pre-service teachers to understand how computer science is important, and making it accessible for K-12 students should be something that they're doing in whatever school that they're in. We want them to have effective strategies so that they can encourage students to think about computer science, and think about computer science in a way that they are creators and not just users of computing technology. Like I said, we integrated it in all different formats of our teacher preparation programs, both at the elementary and secondary kinds of levels. So the secondary math majors, the secondary science majors, even the K-12 Spanish program, all of them are going to get some kind of computer science content, and some kind of integrated content where it's combined with whatever their content area is. So the Spanish methods course, they are doing a little bit related to Spanish and computer science. The other thing that we added is an optional computer science education minor. So for those students who want to take a deeper dive into computer science, we created this minor, which includes the computer science principles course, the Java course, a set of, I think it's 6 credits or 8 credits of electives, and then a methods and field experience course. It's very parallel to the graduate certificate that we have that's offered online, which has 4 courses, kind of an intro computational thinking one, and then the 2 like AP level classes, and finally a CS methods class. So there's some alternatives for students who want to pursue computer science in more depth there as well. This is a graphic that we prepared to try and explain what our program looks like. Before students get into some of that integrated content, they are given a core set of computational thinking modules, and that is spread out over their introductory education courses. So the first, it's like the first 3 or 4 required education courses that they have. They do 1 computational thinking module in each of those courses. So it's maybe 1 to 2 days of classroom work, depending on what they're doing. They're doing some reading about what computer science is. They're trying some hands-on activities. They're doing a little bit of exploration with some disciplinary connections in computer science. And then they're doing a little reflection on equity, computer science standards, pedagogy, those sorts of things as part of that core piece. And then we have the disciplinary connections. So in the social studies methods class, the science methods class, they're doing 1 lesson or 2 lessons that tie in computer science and the content area concepts together. And then finally, they will do one field experience where they create and implement a lesson plan that has computational thinking or computer science concepts incorporated in it. And then, have the support of a field supervisor and their cooperating teacher in doing that. We've done a little bit of training with cooperating teachers in some areas, but need to expand that some more. So that's kind of the overall model. Yeah, there we go. Here's just some examples of some of the integration approaches that we've taken, and feedback welcome. Love to hear what other folks are doing. So it's great to hear what the other programs today had started work on and what they're getting back for results. In our elementary and secondary science methods, we use what was called a coaching process. So a computer science content expert worked with the ed faculty to develop the lesson plan. And for the science methods course, I worked with the science education faculty person, and she wanted to focus in on the engineering design process as part of the science standards. So we looked at that, and then we looked at where there might be some overlap with the computer science standards. And in particular, under algorithms and programming, it talks about an iterative development process and like the basic level of programming with control structures in terms of sequence selection and repetition, just those kind of building blocks of an algorithm. And she put together a nice sequence of activities. So she started them off with an unplugged design challenge where they're thinking about that design process. And then we did a spiral curling activity, which is a really basic one. I don't know how many of you have ever tried curling, but I live in Duluth, Minnesota, and that is home of the Olympic gold medal winning men's curling team. And so curling is big here. It is very big. And you throw a rock on the ice and you use brooms to kind of sweep the ice and melt it and kind of direct where your rock is going. But the idea then is to get the spiral robot to hit a target. And so it's a pretty straightforward one. There's not a ton of code, but it's a nice short activity where students learn how to connect their code to the spiral robot and get it driving in a somewhat straight line. So it's a good activity to scaffold to other spiral ones later. And so they do that as an intro, and then they do the great tape race, which has them using tape laid out on the floor. They have to program directions for the robot to get to 3 different things. So it takes it a step further, and this is where they start to get into some of those other types of control structures in the programming. And then after they're done with those, they kind of put their teacher hat on and they go back and they look at the standards progressions on the computer science side. So they see how it looks different at the elementary, middle, and high school side of things, and what are the layers that we're adding to the content knowledge there. And then they do some exploration of spiral activities by standards. So they look for science standards and what spiral activities align with that. They look for computer science standards and what activities align with that, and do a kind of a journal or a report back about those. So trying to touch on both, the science and the CS standards, as well as bring it back to their teacher hat and thinking about it. Another class that has an integrated approach to it is the children's literature class. So that's one that the elementary majors have to take. And in there, it's making connections to the English language arts standards and then the computer science standards. We use the How to Code a Sandcastle book, and there's an existing lesson plan that's out there. I don't remember off the top of my head who developed it, but I remember watching Vicki Sedgwick at CSTA run a workshop, and this is where they got the idea for it. And anyway, they go through it, and then they do some decomposition with breaking the book pieces into parts and doing mini lesson plans around that and that kind of thing. And then we have a kit, a little, it's not really a bag, but a box of books, including Hello Ruby books and things like that. So then they do some exploration of just thinking about what are other genres, or what else is in the computer science genre, and how might they make connections and think about using them in their classroom. So those are 2 quick examples from Scholastica and our integrated approach, and I'll turn it over to Anne again.
Sure. So our CS supplement, we do a lot of field experiences and field trips for our students to go in through. We have 4 It's a 15 credit add-on. They go through 4 additional courses and they complete 6 weeks of student teaching in a computer science or in an elementary classroom where they focus on teaching computer science. And then they have to take the Pearson test just kind of as a background. This is one of the things that we do every semester is our pre-service teachers design a computer science or computational thinking activity, and then they go in and actually teach it. And it's usually at the elementary level just because that's an easier one for us to implement or have a bunch of students go into different classrooms. So you can see through some of these different pictures, the upper right-hand one is she's in a kindergarten classroom and she's doing BBOTs with number recognition to have students do that way. The one in the bottom is another kindergarten classroom where she's walking them through with Cubeto. I don't know if anybody's kind of played around with that, but she told a story around that for kind of literacy purposes, and then they followed the directions to kind of group things in order. And the one in the bottom right-hand corner, they're doing a hardware or what the inside of a computer is, or the definition of a computer. And so they're integrating physical education by doing movements and dancing in order to remember input, process, storage, and then output, which is one of the code.org kind of lessons that they have fun with. So if you can go to the next one. Yeah, thank you. This is our general elementary classroom. So I also do this for our educational technology course. And this kind of changes every semester. This past semester, because we had partnered with the local school district, and they were implementing one of our previous year's Google grant where students were developing an app to create a culture of kindness using Scratch. And so we had all of our pre-service teachers kind of learn Scratch, and then they actually went out and supported students, 6th grade students in their classrooms with Scratch. So that was a different way to do it. Our EdTech course is one of the very first courses that our pre-service teachers take. So that also adds an additional level of complexity or opportunity, depending on how you want to approach it. I'm going to say it provides a great opportunity because you're getting them before anything has happened, right? So we can talk about ways that it integrates with their subject area and try to get them to be a little bit broader. And it's also one of their first times and experiences with students, being a teacher for many of them. So they really appreciate those field experiences. So can we move forward? Okay, so here are some of the different activities that we do with them. Many of you probably recognize this one from San Francisco, yeah, San Francisco's CS anyway. So this one is the pattern recognition challenge. And so if you go to the next page, this is an example actually of one that we did with my daughter, where we talk about being able to change up the characters to say like it has different ears, legs, tails, and so we can insert different things there and be able to change those around. Thank you, Diane. That's the link. Thank you. You can go to the next one. So I shared that example. I also shared this example just because I thought this was kind of a brilliant example to showcase to many of our earlier elementary students the idea of an algorithm, and that you're doing this all the time as a teacher, right? So you are constantly asking your students to kind of create a series of steps. And then there's this element of debugging, which I thought was so brilliant on the right-hand side, right? Because as you notice with students, what does it mean to walk quietly? We keep our hands and bodies to ourselves, right? So we're going back and we're debugging that particular problem. And then the body is calm, you're facing front because you know that one kid was probably turned backwards. And then as we're walking out, somebody destroyed the science table. So we're going to put something like that in there. So we can go to the next one as an example. The Hello Ruby books that Jen had talked about earlier, I thought there are some really great pieces in that. I wish she would have made the chapters longer, and I think teachers would really appreciate that. But I think that you could expand on a lot of these different pieces and make them interesting. There are a few other ones that I have hidden in the next few slides, so you can unhide those if you want to share those later, Diane. But there's computational fairy tales and Lorem Ipsum, so there are a couple of different ones for higher literacy grades. This is one of my favorite activities, and I do this with my pre-service teachers. This is not an example of things that we created, but something along these lines where we're doing Post-it notes in order to do descriptions. So if you can go to the next slide, Jen, then it shows our pre-service teachers doing this activity. So we just did red green and blue, and then they had to actually code how to do it, and then they took it down, and then somebody else recreated their Post-it note creation. So this helped us get into the RGB type of situation, or talking about how images are actually created. So we can go to the next one. This is another really great one. If you haven't done this activity, we did this activity with our pre-service teachers and they loved it, where it's a sorting network. And the reason why I love this is because it's not just numbers. They also do alphabetizing things. And then the final thing that they end with, which again, I think is just so brilliant, is doing bells. So we also have bells too, to talk about how we sort information and the importance of those pieces as we sort information. And then these are just some of the other activities that we do with our pre-service teachers to kind of talk about the different parts. The one on the left, and these all link to my Twitter so that you can see different examples. But the one on the far left is an example of Code the Teacher, where they actually put scratch blocks together and then they had to do those different pieces. The one in the upper center is one that one of my secondary Spanish teachers created, using the cue. And so he actually programmed it to recognize the flags and then say the flag in Spanish. So I thought that was kind of an interesting integration piece. The one on the upper right-hand side is my elementary teachers. They're exploring Cubeto, and there's storytelling that goes along with it. So there would be retelling elements or things that they would incorporate there. The bottom right-hand side is another example of pre-service teachers that went to a STEM coding night. So that was a extra credit activity where they walked students through how to play with, or what to do with cubelets and bbots. And the cue is on the bottom side there as well. And then the one in the middle, or the left-hand side on the bottom, that's an algorithm activity, which again is from CS Discoveries, I think, where the students are actually trying to tell each other how to create an algorithm or to draw an image. So those are some of the basic ideas that we do. The other things that we've kind of looked at have been looking heavily into data and data sciences. So we've shown them a lot of like Google Trends so that they can play around with data. I think that's one of the best references or the best ways to do it for our secondary pre-service teachers. In other areas, especially like social studies or English language arts, that often have a difficult time seeing the relevance of computational thinking or computer science.
So just a little summary and kind of some of the lessons we've learned. I think even what you're seeing in Maryland, it's definitely possible to put computer science pre-service programs into schools in a whole variety of different ways. Right now, there's a fragmented approach, so it's great to see Diane bringing all of you together to be able to discuss and talk about different approaches and have that kind of community to have the conversation. One thing I would encourage you all to think about as you're getting programs off the ground is thinking about how do you bring more and more faculty members into the mix and supporting computer science, so it's not just you and the one person in computer science who's excited about this, right? So that if something happens and you're no longer at that institution, the program can continue on after you're gone. Let's see, a lot of, you're lucky that you're all in the same location. When you start looking at programs across the country, like the differences between mine and Anne's program is influenced a lot by our local context and what our policies and state regulations are around that, or the lack of them in my case. And then just a couple of thoughts around, or maybe questions around integration. There are a number of resources available. I put some of the ones that I've looked at and used as well. And I think, Anne mentioned a number of hers too in the notes part of the slide. So if you open it up and it is in the folder, a copy of it's in the folder, so you should be able to see it. Just thinking about like, what is the right amount of computer science content? Are you giving them enough throughout the program so that they're able to create those lessons or feel confident researching and finding lessons later on and, continuing their computer science learning? I'm thinking a little bit about like the goal and the depth of the integration and how much are you balancing teaching computer science versus teaching the content area? Are you doing a little bit of direct instruction of both? And, depending on the context, it might be more about the content area, it might be more about computer science, and how are you thinking about those things? academic vocabulary, assessments? Are you aligning with the standards there so that you're assessing both the computer science knowledge and the content area knowledge if that was the goal of the lesson? So just some things to think about in terms of integration. Looks like do we have a couple of minutes for Q&A there too, Diane? We do. And did you have something else you wanted to add?
Yeah, I think the one thing I just wanted to add is the biggest, I feel like, deficit that we face is that, or maybe again, or opportunity, depending on how you look at it, is just that most of these pre-service teachers have not either had experience with CS before, or they've never seen a really good example of what computational thinking or computer science looks like integrated, right? And I think that's something that we all struggle with. What does that look like? What are good examples, and what can we kind of put forward as a way to say, this is what we should be striving for? That's hard.